In this video, we're going to use the second fundamental theorem of calculus along with the chain rule and U substitution to find the capital F prime of x. So we're given that the capital F of x is equal to the integral from 2 to x squared cosine t dt. And we're asked to find capital F prime of x. Okay, so notice that in order to use the fundamental theorem of calculus, you have to make sure that the x is to the first power. But since it's to the second power, you can introduce another variable in terms of x squared, right? So we will say that the u, in this case we're using the u substitution, u as a function of x is equal to x squared, okay? So now this f prime of x becomes simply 2 from 2 to the ux, right? U as a function of x, cosine t dt. And notice that we can still use the fundamental theorem of calculus because the u, even though the u is another variable, but it's in terms of x, right? It's a function of x as well. So we can still remain with the capital F of x as before. So now the fundamental theorem tells us that the capital F prime of x will be simply the cosine of u of x, right? Cosine of u of x. But we're not done yet, because even though ux is inserted into the t, using the chain rule, we still have to differentiate the u to the x function, right? So we have to multiply this part by the u prime of x. Okay, because we have to follow the chain rule when we're taking the derivative, right? And the u prime of x can be deduced from this substitution here, right? So the u prime of x is going to be simply 2x, right? Using the power rule of differentiation. So now this is going to be simply cosine, and u to the x can be substituted back into the x squared multiplied by the u prime of x, which is 2x. Okay, so the final answer is going to be 2x cosine x squared. Okay, so this is how you find a derivative with the u substitution, with the chain rule, and the fundamental theorem of calculus part 2. Thanks so much for watching. Please subscribe to my channel, and I'll see you in my next video.